Hello, good morning. So today I will be showcasing you a project that I recently completed. This project is basically a chatbot, AI powered chatbot that I have built. So I was given a project last week only, and the deadline was around 5 days to build a RAG application chatbot for two airports that are based at Singapore. One is Changi Airport, as you can see in the screen. So this is the Changi Airport, and this is the Jewel Airport. So whatever the data was there inside in this website, I was requested to scrap the data and build a RAG application chatbot. So and deploy it in the server. Okay, so I completed that project within time. So let me just give you a quick walkthrough of the project. Okay, so first what I did was that I used this the entire workflow of this this code. You can see it here. Okay, I made some this separate folders for log, and then custom Jenkins, since it was deployed used in Kubernetes engine. Okay, so I used CI for CI/CD deployment tools. I used Jenkins, okay, and Git and GitHub in order to transport that this entire code base into the by containerizing it into the Docker, and then I send it to Kubernetes. Okay, so firstly what I did is that I used this webloader.py file. Okay, I didn't use recursive character sorry I didn't use the web based loader. So the entire workflow I used was LangChain only, because LangChain provides you various features like web based loader, okay, and RAG applications also, and also it is compatible with lot of LLMs, okay, whether it be OpenAI or any gamma model or any models. It is compatible with almost all models. Okay, so I used this particular library LangChain. So what I did is that I didn't use web-based loader. I used recursive URL loader here, because web-based loader, what it does, that it only scraps the first page, that URL which you are giving. Okay, so it only scraps those data only. Okay, but recursive URL loader, what it does is that it goes deep into the website. Okay, so as you can see, I have mentioned here max depth up to 3 I have taken. Okay, so it's a decent number, and most of the data was scrapped, okay, using this. So this file this particular Python file, what it did is it went to both the websites, and then it just scrapped the entire data. Okay, then after that I used this data loader. Okay, no, sorry, I use this vector store .py file. Okay, so when the entire data was scrapped, I used this vector store.py file in order to convert the entire natural language data into vector data, and store it in the Pinecone DB. The specific reason for choosing Pinecone DB was that firstly the data is stored in the server, so you don't need to so your while you import the data into the Docker, so you won't be having that extra cost which you will be bearing if you use the Fias or any other vector database. Okay, so this is its speciality. Okay, so the data will is I think the data is stored in the AWS server. Okay, and no charges are there. Okay, so this is the code for it. Okay, then I used embedding layer. Okay, so I used open source Hugging Face embedding for it. So the name of the model is all mini L6v2. Okay, so and the device is CPU. Okay, so this Hugging Face embedding, what it will do is that it will just convert the it will add an embedding layer into that vector database, and whatever the data is there, using the cosine similarity, it will be giving the similar vectors, okay, in natural language form. Okay, so and then for LLM, I used this Chat Grok API. It's also one of the open source API. Okay, it provides you free per day quota limit is there. Okay, but it's good for testing, Okay, so I use this. So all you cannot see anything because that .env file I can't show it to you. Okay, I cannot upload it into the GitHub, right? That's why. Okay, so after doing all this thing, what I did was that I just containerized all this entire code base into Docker. Okay, and this is my Docker file. Okay, so as you can see, using Jenkins, I did all this thing, executed all this, and yes, let me just show you this Jenkins file. So this is the deployment.yaml file that I made. So as you can see, replicas 2, that means in the Kubernetes engine 2 replicas will be there, that will be running, 2 engines will be running. This is the name of the project, this is the Docker image. Okay, so I have all the credentials. I have just mentioned it here because in GitHub you cannot add the credentials. So rather I just uploaded the credential in the Jenkins credential section. Okay, and lastly, this is the Jenkins file. So as you can see the steps here. So firstly, the cloning of the GitHub repo to Jenkins. Okay, so this is the just you need to copy it from GitHub. Okay, then the second stage is making virtual environment. In that Linux command line, you need to make this uh, virtual environment. You need to install all the dependencies and all. Okay, after installing, creating environment, installing Python, creating all the dependencies, what I did is that I build and push the GCR image to push the Docker image to the GCR, that is Google Container Register. Okay, and after this, the deployment of the entire Docker image into the Kubernetes engine, I did the next step. Okay, and as you can see, uh, so this is how I completed the project after deploying. So I since this project I had after I hand over the project, I just removed the I just decommissioned the entire project because it was costing me money to host it into my server. So this was the entire interface. I used Flask to design the interface. Okay, so as you can see how to access the wheelchair facility, it is showing the giving the correct results. Okay, so this was the entire flow. What I will be doing is that I'll be just attaching manual testing report and along with and also the final report uh, with the uh, with the video. Okay, so you can just go through it and check in details what all things I have mentioned there. Thank you.